Hey guys, so today we're going to be taking a look on how you solve this problem, and we're going to be solving it by looking at this formula, which may look familiar to you. It is called the integration by parts formula. So we are going to be using this to find the answer to this basically. So let's get started. So before I unveil the solution, make sure you give this problem a try because it is a tricky problem, but don't overthink it. The solution is actually pretty simple. So I'm just going to show you the solution right now. So I'm just going to write this as it is for the first step. So sine x to the power n dx. We can rewrite this as the integration of sine x to the power n minus 1 times sine x dx. Now we can apply our integration by parts formula in here, because we have f of x and g of x. So let's leave this as it is. Integration of sine of x is basically minus cos of x. And why did I do that? Because you see, if you take the derivative of minus cos of x, you get sine of x. And you see over here, it has to be g of x prime, as you can see on the left side of the integration by parts formula. So now that we have this in terms of this, we can easily apply the right-hand side of our integration by parts formula. And we do this by multiplying these two together. So cos x sine n minus 1x minus the derivative of this, sine x n minus 1 times minus cos x. Alright, now that we have that, well, essentially I'm just gonna, these two multiplied is just positive, so I'm just gonna leave a positive right there. And now we're just gonna leave this the same, minus cos x. And let's take the derivative of this. Now, we just use the chain rule for taking the derivative of this. If you don't know what the chain rule is, just research that. It's not that hard. But you do need the chain rule in order to find the derivative of this. So I'm just going to do the chain rule quickly on this side. Alright, so I'm going to replace this in for this right now. So this x and minus 2 cos x times cos x. There we go. And this is just going to stay the same. I'm not going to rewrite it. I'm just going to put that there. Here's a plus. And we know that n minus 1 is a constant because you see in the question it said n is an integer. So we can take that out. And we can write everything as it is. So sine of x to the power n minus 2 times cos square x dx. Forgot dx. Okay, dx over here. And now I'm just gonna rewrite this. Cos x sine n minus 1x plus n minus 1 integration of this to x. And now I'm going to convert this in terms of sine. And you will know why, because I'm not sure if you noticed just yet, but this is actually equal to this right over here. So we're getting close. Now we just need to handle this part. And you see that I and minus 2, you see that's just going to include sine, right? But we have a cos over here, so I just want to get rid of the cos. That's why I'm going to convert it into sine. So this is basically 1 minus sine square x dx this time. And Alright, so I'm just going to rewrite this here. Let's expand this, so let's rewrite this as it is. Cos x sine x to the power n minus 1 plus n minus 1. And let's just expand this, so we get sine of x to the power n minus 2 minus sine of nx dx. And let's rewrite this as it is. And let's keep in mind that on this side it's in, just to point that out. And now we can do n minus 1. And we see that we can split this into the integration of sine n minus 2x minus the integration of sine of x to the power of n. So let's just do that. So after that, we can say that we see that the integration of sine x to the power n minus 1 is basically I n minus 2. So we could rewrite that as I n minus 2. And we see that this integration of this is just simply in, so we can just rewrite that. And let's rewrite this whole thing once again. And here I'm just going to expand n minus 1 to both terms. Alright, now that we have that, we need to have in on just one side, but we have one on this side. So let's just take this on this side. And then right now I'm just rewriting everything as it is. Alright, now time to simplify this. This is my bad. Everything on this side simply stays the same. And this get canceled out. We have in is equal to everything here. And in order to isolate in, we need to divide both sides by n. So I'm just going to erase the last row. And then you get in, divide both sides by n, so minus cos x sine x n minus 1 plus n minus 1 n minus 2 over n. Or you could take the n out and simply multiply it by 1 over n, which is exactly what they did here, but this and this are exactly the same. So yeah, that's how you solve this tricky problem. As long as you know the integration by parts and the chain rule, then you are all set to solve problems like these.